Okay, students, let's continue with 7.1 to 7.2. We're going to go to the next example, example 4, where we're solving for a triangle, but it has two possible solutions. So it gets a little bit more complicated. Okay, example 4, solve triangle ABC if A is 35.5, B is 39.2, and A is 61.4. So right off the bat, we could use the law of sines to solve for angle B, right? Because we've got A, B, A, and then we would just have B. So let's go ahead and do that. Let's set up a triangle here and see what we can look at. We have, I'm going to call this angle A here. Okay, and I'm going to call this guy angle B. Okay, maybe I'll make this angle a little less steep. Okay, and so we'll call this angle B. Now, in this case, we could have an angle B here, or we could have angle B here. Okay, so there's two different cases here. We don't necessarily know what's going to happen, but angle A is 61.4 degrees, and angle B is what we're looking for. We're looking for angle B, but again, there's going to be two possibilities for this one. There's going to be an acute angle B, and there's going to be an obtuse angle B, and we'll see that in a minute why that is. Okay, it's because when we take the sine of the angle, it produces two values. Okay, so the side that's opposite angle A is side A, and that's the 35.5. And the side B that's opposite angle B, regardless of whether it's acute or obtuse, is 39.2. So we can go sine B over B is equal to sine C over C, or sorry, sine A over A. Okay, and so sine B over B, what was B? 39.2? 9.2 is equal to sine of A, 61.4, all over the A, which is 35.5. I can multiply both sides by 39.2, and I'll get sine B to be equal to approximately what? Let's put a calculator on this. So we have sine 61.4 load. Okay, sine of 61.4. Okay, and then divided by 35.5 times 39.2 divided by 35.5 times 39.2, and that gives me about 0.969, basically. Okay, and so let's think about that for a second. I'm going to write that out here. Sine B is approximately 0.969. Okay, so is that okay? Is that a value that is okay? Yes, it is. It's less than 1, which is good. Okay, because once again, sine has to be between -1 and +1, so that's a good one. But when we solve for B here, we could use inverse sine, but that's only going to give us one of the possible values. Okay, one value for the angle where sines are positive is going to be in the first quadrant, but there's another angle in the second quadrant that will have a sine value that's positive. And so B is going to take on two different values. Okay, so let's see what those two values could be. No pun intended. Okay, so we're going to take the inverse sine of the answer that we got, and I get 75.81 degrees. Okay, now that's just the reference angle that's in quadrant 1. How do I find the quadrant 2 angle? Well, I subtract this angle from 180. 180 minus that angle is 104.19. So we have two angles here that are valid angles. One is an acute angle, which we talked about, and one is an obtuse angle, which we talked about. They're two valid angles. So we end up with solving for two different triangles. Let's go ahead and do that. Okay, so angle B is either 75.81. Okay, I'll just call it 75.8 degrees. Okay, or 104.2 degrees. Okay, so B is this. So that has us set up for two triangles. I'll call this triangle 1. Oops. Triangle 1 and triangle 2. Okay, so triangle 1, okay, is when B is equal to 75.8 degrees. Okay, so if B is 75.8 degrees, how do we find angle C? Well, we just subtract the angles that we know. What do we know? We know angle B, we know angle A. We subtract the angles that we know from 180 and we get angle C. So angle C is equal to 180 minus 61.4 minus 75.8. So angle C is going to be what? 180 minus 61.4 minus 75.8 is 42.8. Okay, so that's 42.8 degrees. So that's angle C. Now, how would we find side C? Okay, we know two sides. Okay, we have an angle and two sides. Okay, side 1, side 2. We need to find side C. Well, we're just going to use the law of sines to do that. So maybe I'll use angle A. So I'm not rounding too many things. Okay, we've got side A and we've got angle A. So that'll help us out. Sine A over A is equal to sine C over C. So I want to solve for little c here. I'm going to cross multiply and divide. So C times sine A is equal to A times sine C. Divide by sine A. Okay, and so C is going to be equal to A. What's A? A is 35.5. The sine of C we calculated out to be the 42.8. So sine of 42.8 all over all over the sine of A, and A was the 61.4. So sine 61.4. Okay, so C is approximately what? So 35.5 times the sine of what? What was C again? 42.8 times the sine of 42.8 divided by the sine of 61.4 equals about 27 point, we'll round it up, 0.5. So 27.5, and this is a side, not an angle. So 27.5, and what were my units here? Centimeters. So we'll round to the nearest tenth of a centimeter. And so C is that. Okay, so we solved for triangle 1. That's when B was an acute angle, okay? That's when B was this angle here. Okay, what happens when B is an obtuse angle? Okay, because it could potentially have been an obtuse angle. It could have been this 104.2, right? Okay, there's the two angles that B could have been. Could have been that 104.2. So we'll just do the same thing. But again, yeah, these are a little bit of extra work because we're having to do basically two problems in one. So this is 104.2 degrees. So that's B. So now what's going to be angle C? Well, C is equal to 180 minus 61.4 minus 104.2. Now, hopefully this works. If it doesn't work, then we only have one triangle. If this gives me a negative value, we only have one triangle that exists. So, but in this case, I think this is going to give me a positive value. Okay, when I subtract this, this is 180 minus 61.4 minus 104.2. Okay, and that's 14.4 degrees. Okay, so C is equal to 14.4 degrees. And we basically have the same setup as before. Sine A over A is equal to sine C over C. Because we want to find side C now. Okay, it should be shorter than the 27.5 because the angle is now obtuse, which means that this side C here, okay, this side C, which is right there, that side C should be shorter. Okay, because it's an obtuse angle. So sine A, it's going to cross multiply. We get C sine A, it's the same thing that we had before, is equal to A sine C divided by sine A. Okay, so C is equal to A, which is 35.5. The only thing that changes here is the angle. So A is 35.5 sine of 104.2 over the sine of 61.4. So because very little changed, I can actually go up here and grab this. If you have a copy function on your calculator, some do and some don't, depending on the age of the calculator, but I'm just going to grab that there. And what I can do is I can do something called insert. I'm going to delete 42.8. If I hit delete, 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 delete. And now what I'm going to do is I'm going to do insert. So that second delete will change the cursor. Now allow me to insert 104.2. Okay. Is that right? Angle, no, we want angle C, I'm sorry. Angle C was the 14.4 that we calculated. 14.4, delete. Okay, that's the new angle, angle C, right? 14 point, no. Yeah, angle C, correct. Angle C is now less because it's opposite the side that's less, yes. Okay, so that gives me about 10.05, or we'll round to 0.1, 10.1. Okay, so this is C is equal to, oops. Come on, be nice. C is equal to 10.1, and that's centimeters. Okay, so again, two triangles here. Okay, one where angle B is acute and one where angle B is obtuse. Okay, and one where we get a long 27.5 centimeter angle side C, and one where we get a short 10.1 side C. Okay, example 5, solve the triangle ABC if A is 19.6, B is 25.1, and B. So again, we're gonna set this up. Let's look at what we got here. Okay, so this is A, okay, and then they give us, actually, let's call this angle B. Okay, we'll just reorient the angle, the triangle. Angle B is opposite side B. Okay, and they're saying side B is 25.4 and the angle is 68.7. Okay, and so angle A is going to be here, and that's going to be opposite 19.6. And then angle C will be there, and that's opposite side C. Okay. So let's see what we can do here. We have B, B, and A. We need angle A is what we're looking for. So we're going to go sine A over A is equal to sine B over B. Okay. Okay, so if I just multiply both sides by A, I get sine A is equal to A over B times sine B. Okay. So sine of A is equal to 19.6 over 25.4 times the sine of B, which is 68.7. So the sine of A is equal to what? So the sine of A is going to be equal to, we have 19.6 divided by 25.5, or sorry, 25.4 times the sine of 68.7. Okay, is about 0.718 or 0.719. Okay, if I take the inverse sine of that, I get 45.96 or about 46 degrees. Okay, which is my quadrant 1 reference angle. Again, there is another angle here in quadrant 2. Okay, so if I go 180 minus this angle, okay, I get about 134 degree angle. So we know that the sine of angle A was approximately 0.719. So A could have been equal to 46 degrees or 134 degrees. Okay, so let's look at the first triangle. Okay, however, let me look at the obtuse angle here real quick, because I can eliminate a triangle right now. Why? Because if I let angle A be 134 degrees and angle B is a 68, well, isn't that more than 180? Isn't 134 plus 68.7? What does that equal? 134 plus 68.7. Okay, it's about 202. And can you have 202 degrees in a triangle? No. Come on, behave. Okay, so no, you cannot. You cannot have 202. So we know that this is a false angle. We know there's really only one triangle that can occur here. Okay, this 202 is greater than 180. I'll put it a little greater than 180. So no triangle, or we should say no second triangle exists. And so we only have triangle 1. Well, what is triangle 1? Well, triangle 1, the only triangle, is going to be when A is equal to 46 degrees. Okay, then what is angle C going to have to be? What's angle C going to have to be? Well, it's going to have to be C is equal to 180 minus 46 minus 68.7. So 180 minus 46 minus 68.7 is 65.3 degrees for the angle C. So 5.3 degrees for angle C. So so angle A was equal to this. Angle C was equal to that. Okay, so now what's side C? Well, let's reference the two B's here that they give us. Okay, so sine C over C is equal to, okay, well, let's do sine B. Sine B over B is equal, little b, B is equal to sine C over C, okay? Okay, because I want side C, with this little side C. So cross multiply, C times sine B is equal to B times sine C, okay? And divide by sine B, and we get side C is equal to B sine C. So B was 25.4. Sine C, that's the sine of 65.3, all over the sine of B, which was 68.7. Okay. So let's plug that into the calculator and see what this comes out to. 25.4, 65.3, and 68.7. 25.4 times the sine of 65.3 divided by the sine of 68.7. Okay, it's about 24.7 or 24.8, I would say. Okay, so about 24.8, and it's inches in this case, inches. So we only had one triangle in that case. Okay, because when we got the angle A, it was an angle that couldn't exist and make a triangle. It could exist as a sine value, but it can't exist inside a triangle because it made the triangle go to the angle. Some of the angles were too large, and so it couldn't exist. Okay, area of a triangle, we're actually going to work with two different area formulas. This is the first one, based on the law of sines. Okay, the area of any triangle given by area triangle is equal to 1/2 B times C, these are sides, BC times the sine of what's called the included angle. The included angle is the angle between two sides. Okay, so this angle A is, we call that the included angle. Okay, so we're going to do SAS here. It's included, right? Side angle, side angle, side. Okay, the angle is in between the two sides. Okay, so from the area formula below, above is used when the height of the triangle is not given. Okay, so find the area of each triangle. Okay, so let's draw a triangle here. See what we're given and what's missing. Okay, so we're given a couple angles and a side. Okay, what we need is a couple of sides and an angle. So we're given an angle. Let's call this angle A. That's opposite side A, 32.5. Okay. We'll call this angle B, which is 58 degrees, 10 minutes. Okay, and so I could really write this as 58 and 10 over 60, or 58 and 1/6 degrees. I'm gonna leave it like that. That's angle B, 58 and 1/6 degrees. Okay, and then angle C, I'll call this angle C up here, that's 73/30. Well, 73/30, 30 over 60 is 73.5. Okay, so we've got C is 73.5 degrees. Okay, which should tell us what angle A is. Okay, that shouldn't be too hard of an angle to get. Okay, because I can just subtract that from 180. 180 angle A is equal to 180 minus 73.5 minus 58 and 1/6. Okay. 73.5, that's a half. Okay, so I guess we go to the calculator on that one. So 180 minus 73.5 minus 58 and 1/6. So 180 minus 73.5, right? Minus 58. Well, I'm going to put this in parentheses. I don't like the fraction. 58 plus 1/6. Okay, that's 58 and 1/6. But I'm subtracting the whole thing, so I have to subtract both the whole number value and the fraction. And that's 48.3 forever, which is 48 and 1/3. Okay, so this angle A is 48 and 1/3 degrees. Okay, so 48 and 1/3 degrees there. Okay, so now what I can do is get the law of sines, because I'd like to get an adjacent side here for one of these angles that they give me. They gave me angle C, so if I could find side B, that would be really useful. I have side A. I would just want to get side B, or I could find side C. It really doesn't matter. Okay, either way. Okay, but it would be nice to get side B there. So let's find side B. Okay, using angle A and side A. So sine A over A is equal to sine B over B. Okay. So how do I get side B? If I cross multiply and divide, I get B is equal to A sine B over sine A. Okay. And so B is approximately, what is this going to be? A is 32.5. The sine of B we found to be 58 and 1/6, all over the sine of A, which was 48 and 1/3. Okay, so go to the calculator. 32.5 times the sine of 58 and 1/6, 58 plus 1 divided by 6, divided by the sine of 48 and 1/3, 48 plus 1/3. Okay, is about 36.962. Okay, so 36.962. So B is equal to 36.962, almost exactly. So that's 36.962 down there. So now I want to use the angle. So that was side B, not side C. Okay, I want to use the triangle formula. Let's use that triangle formula. Okay, so we're going to use, gosh, I don't know why it does that all the time. But where this is 36.962, I'm not going to round just yet because I want my area to be as accurate as possible. So I'm going to use the values that you see here. Okay, to get this is going to be B, little b, and little a, and the angle C. So the area of the triangle is equal to 1/2 the two sides multiplied together, 36.962 times 32.5 times the sine of the included angle. So the sine of 73.5. Okay, maybe I'll move this over a little bit. Resize that a little bit. Okay. Just resize for me. It's not going to work. Nope. There we go. Move that over. Just a touch. Okay. So now we just plug that into the calculator. So the area is equal to 1/2, which is 0.5, times, what do we say? 36.9, that's the previous value that I got there, times the 32.5, right? 32.5, yep. 32.5 times the sine of 73.5. Okay, which is 575 point, we'll say 9. Okay, and you're like, why is that so big? 575.9. Where'd my screen go? Okay, and the reason it's so big is because it's square units. Okay, it's area. I can exit out of that and reboot it. Okay, so the area is about 575.9, and it's square centimeters, so it's square units. Okay. Okay, let's do the last example here, B. Okay, again, we have an angle, a side, an angle. I'd like to get another side. I'd maybe like to get side C here. Okay, so let's find out what angle B is first, because that's the only way we can use law of sines, because we have these sides and we have these sides, this side angle pair and this side angle pair. And I'd really like to find out, what is angle A? What's side A? Okay, or side C, either way, based on the side that is given to us, and the only way we can get angle relationship for the side that's given to us, okay, opposite B, is to find out what angle B is. So let's, basically it's the same setup as before. Okay, so angle B is going to be equal to 180 minus 24 and 40 over 60. Okay, 24 and 40 over 60 degrees minus 52 and 40 over 60 degrees. Okay. What's B going to be equal to? Okay, 40 over 60, that reduces to 2/3. Okay, so that's going to be 180 minus 24 and 2/3. 24 plus 2 over 3 minus, and then that's 52, right? So 52, 40 over 60, that reduces to 2/3, 2/3, 2/3. So that's 52 plus 2 over 3. And that's 102.6 forever. That's 102 and 2/3. So 0.6 forever is 2/3. So that's 102. B is 102. So this is an obtuse triangle. Okay, 102 and 2/3. Or 102 and 40 minutes. Okay, 102 degrees, 102 and 2/3 degrees. Okay. And so again, in order to use the area formula, I have to get an included angle. I have to get an angle that's included between two sides. I have to get two sides and the included angle. And so I either need to get side A or side C. Okay, so I'm going to get side C here. And then I'm going to use this angle, this side, and this side to get my area. So let's first figure out what side C is. Okay, now I can go sine B over B is equal to sine C over C. Okay, so the sine, so cross multiply, I want to find out what side C is. C sine B is equal to B sine C divided by sine B. And C is equal to B, which was 27.3. 27.3 times the sine of C, and C was 52 and 2/3, all over the sine of B, which we calculated to be 102 and 2/3. So side C is approximately what? Okay, so 27.3, 52 and 2/3. Okay, so let's plug that in the calculator. So we wanted 27.3 times the sine of 52 and 2/3 divided by the sine of 102 and 2/3. Okay, boom, we got about 22.25 centimeters. 22.25 centimeters is C. Okay, 22.25. So C ends up being about 22.25 centimeters. 22.25. Okay, so now I want to find the area. Well, the area is just 1/2, okay, of the two sides and the included angle. the two sides being 22.25 times 27.3 times the sine of the included angle, which is the 24.40, or 24 and 2/3, not 0.40, it's 40/60th, 24 and 2/3. Okay, so let's multiply that out. 0.5 times 27.3 times 22.25 times the sine of 24 and 2/3. Is that right? Yeah, 24 and 2/3. 4 and 2/3. And we get 126.75, and I believe that's centimeters. So area is equal to 126.75, and that's centimeters squared because it's area. Okay, units are in centimeters. Okay, so that's 7.1 and 7.2, and I will see you guys in the next video.